Pause. Hoodie Math welcomes you in. 4.2 Laplace Transforms. Big section. We just learned how to derive some of these Laplace Transforms. Now we have a table, hopefully you downloaded from Canvas. So we're going to be using this table to help us identify some of these Laplace Transforms and how we would rewrite them. So let's go ahead and begin. Hopefully you print that out and have that handy because that is imperative as we move forward. So let's begin. Find the Laplace transform for the given functions. If we're looking at 6 times e to the negative 5t, and you have your formula sheet out, shouldn't be too hard to find it. Anytime we have e to the at, we're going to use 1 over s minus a. So I'm just going to go first and identify some of these above. 1 over s minus a. S is the variable in our function. A will be the term in the exponent. 6 is just a coefficient out in front. E to the 3t. So again, another exponential. 1 over s minus a. And we'd have a new a with 3. 5t cubed. So now we're on number 3, t to the n. So n factorial over s n plus 1. I'm just going to write that one down for now. N factorial s n plus 1. And then we have a constant, and we derive constants. If it's just a 1, it's 1 over s. Ours will be 9 over s. But for now, I'm going to put 1 over s. Because 9 is a coefficient, right? Okay, so let's transform. So what's the notation we should use? Well, you could say the Laplace transform of f of t. And later we'll just call this f of s, because we're going to use s as our variable. So these two can be used either one. So 6 is out in front. 1 over s minus a. A is negative 5. So 1 over s minus negative 5. Obviously, I'd write that as plus 5. Just trying to show you, we have a 1 as a coefficient. It's going to be 1 over s minus 3 for e to the 3t. 5t cubed. N is 3. We have the 5 in front. N factorial. N is 3. 3 factorial over 3 plus 1. Which will be 4. Eventually I'd write that as 4. Just for the first one, I wanted to practice writing it all out. Minus 9 times 1 over s. That's the constant at the end. So cleaning some of this up, maybe we could write this as 6 over s plus 5. Plus 1 over s minus 3. Sorry, those s's looks like 5. This is an s. This is an s. Plus, well, this would be, what, 3 times 2 is 6. We'd have 30 on top if we really wanted to. And then s to the 4th power minus 9/5. So we transformed that function to a Laplace transform. Pretty neat. Let's move on to number 2. So first few examples, we're just identifying from the Laplace transform. So look at your table, cosine 4t, find it. Which is number 8. So cosine and sines are very similar. Cosine is s over s squared plus a squared. And sine is a over s squared plus a squared. Kind of recommend writing a few of these out as we get started. The more you write it out, the easier it becomes, and the more you memorize them and see patterns, right? Okay, cosine 10t. So back to the first one. S over s squared plus a squared. S is not my strongest variable, I'm going to say. Laplace transform of g of t, or you can just say capital G of s. So 4 is a coefficient. We'll have s over s squared. A is 4. And you can identify that from the function, right? So cosine AT. A is in front of t. So 4 squared is 16. Minus 9 sine of 4t. A little different now. Put the a on top. 4 over s squared plus 16 plus 2. And again, cosine back to the original. S over s squared plus 10 squared, which is 1 hundo. And that's done. That's converted to Laplace transform. Moving on. Number 3. So again, now we have an h2t, a little bit different than what we just did, right? So 17 sine h at, which looks like this. A over s squared minus a squared. Again, this is number 17 on the table I shared with you on Canvas. And then we have just the sign of the regular, which is just a over s squared plus a squared. So just the minus is the difference, right? Difference of squares versus a prime factor in the bottom. So capital H of s, high school. 3 in front, sine h2t. A is 2, so 2 goes on top. S squared minus 4 plus another 3. Coefficient is 3 here. Sine 2t. A is 2. S squared plus 4. So there's our Laplace transform. Hopefully you're kind of finding this easy once you know where to identify it on the table. Again, that's why I kind of said it's a function inside another function in the first video. Functions of a function. Number 4. It's going to get interesting real quick here coming up. I'm just going to keep identifying these as practice. 1 over s minus a. No h in front here, so that one's just going to be s over s squared plus a squared. And feel free to pause the videos and just identify them for yourself. Now this is a new one, right? So we just keep practicing some new examples. If you looked on your table, see if you can find it. Pause the video if you'd like. It's number 20. E to the at cosine bt. So s minus a squared plus b squared. A is the coefficient of e and b is the inside of cosine. So each of these Laplace transforms, just using it from the table, you could derive this if you wanted to for extra practice. And again, if you had the cosine hbt, you would have something a little bit different, right? Okay, so let's go ahead. Let's plug these in. Capital G of s, Laplace transform. Again, you could have said also Laplace transform of g of t. Those are the same. E to 3t, a is 3, 1 over s minus 3, plus cosine 6t, a is 6, so s over s squared plus 36, minus s minus a. Again, a is the inside here. This is a, this is b. So s minus 3 all over s minus a, s minus 3 squared, minus b squared, 6 squared, 36. And I'll leave it just like that. If you want to clean it up, go for it. All right, number 5. So t cosine h3t, where are we going to find this? And you're not going to find it. It's not on the list. But what we're going to use is number 30. And we're going to use 30 for a lot of the examples coming up, where you have a linear term in front, and then you have some function here. So this is going to be in the format of t to the n. And then we already have ft out here. I would call this f of t. We can just keep it easy for you guys. I'll change it from my notes. Never a good idea. I'm going to make that a g of t, and then we'll just call this f of t like the notes. or like the formula sheets. And now I got to convert my notes as we go. All right. So n is 1. You know that's the first power. So if you look at the formula on number 30, it's -1 to some n power, right? And then f n s. And then we know n is 1. So -1 to the first power. And we're going to do the Laplace transform of the first derivative. All right, so now we need to identify this part. So let me make sure I have plenty of room. Let's do that over here. So if f of t, again, I've renamed this g of t. So if f of t is cosine h3t, what would the Laplace transform be of that? What would f of s be? Well, if you can find that one, it's one we worked on before. Or we worked on something similar. Will be number 18, s over s squared minus a squared. So s over s squared minus a squared, so 9. Plus 3 is a. So we need to take the derivative of that because we're going to do the first derivative. So what's the derivative of this? Well, quotient rule. I always was taught a song, low d high minus high d low over low low. Shot out to my my brief calculus teacher at Gateway Community College. All right, s squared minus 9, low d high, low d high, derivative of the high is 1, minus high s, d low, derivative of the low, just 2s, all over low low. It was like the sound of music or something. High d low over low d high over low low. Never do that in class, but I'll do it behind the screen. All right, so that is our derivative of the Laplace transform, which we're going to plug in here. So we can probably clean this up, right? S squared minus 2s squared is going to be a negative s squared minus 9 all over s squared minus 9 squared. We can probably take out a -1. Oh, wait, when we plug it back in, there's going to be a -1. So this is going to be g of t, which means g of s is our Laplace transform. And I'm going to -1 times this is now going to be s squared plus 9 over s squared minus 9 squared. So this is our final answer when I'm boxing in here. So again, what we did is we identified it as number 30. This is some Laplace transform f and s. And we have to do the first one because we know n is 1. So if this is our f of t, we need to have the Laplace transform of that, which would be s over s squared minus 9. We need the derivative. So we did the quotient rule, got the quotient rule, simplified, plugged it in, times -1, and that just cleaned up the top, made it all positive. All right, let's move on. All right, number 6. So something very similar. Now we're just going to have to the second power, right? So n is now 2. This is now our f of t. So we would start off by saying -1 to the second power and f double prime of s, because again, this fits in with 30. It's a linear term, or t to some power, not a linear term, t to some power times some other function, which we have here. T to some power and then some other function. All right, so now we need to get to this point. So if f of t equals sine of 2t, we need to take the Laplace transform. F of s. Well, Laplace transform, it's a over s squared plus a squared. So a is 2. 2 over s squared plus 4. We need to get to the second derivative. So here's the first derivative. I did this a couple ways. I rewrote this one as 2 times s squared plus 4 to the -1 because I knew that derivative would be easier. So it's going to be negative 2 times s squared plus 4 to the negative 2 times the product rule 2s, or you could have just done the quotient rule, which you would get in the same thing anyways, which is going to be negative 4s over s squared plus 4. Since now I have a term on top, I did the quotient rule on the next one. So the second derivative, low d high, derivative of the high would be negative 4 minus high d low. Derivative of the low would be 2 times s squared plus 4, chain rule to s, all over low low. Squared squared. So it's going to be 4 in the bottom. All right, so cleaning this up, you can check yourself and do the math, but I'm just going to write the cleaned up version. It's 12s squared minus 16 all over s squared plus 4 cubed. Basically give you a rundown of what I did. Simplified everything. I took an s squared plus 4 out of both of these terms, which cancel the bottom with 4, making it 3. Since this s squared plus 4 term went down to 1, I multiplied it in with negative 4. I have a 16s here. 16s squared, which made 12, with the 4s squared became 12. So you can check on that, but I did factor out an s squared plus 4 and then combine terms. All right, so back to the top. Negative 1 squared, that's positive, so it's just the second derivative. So h of s, the Laplace transform, was going to end up being 12s squared minus 16 over s squared plus 4 cubed. And that would be the final answer for our Laplace transform. Cool. Let's move on to the next one. 7 and 8 are the easiest ones, and 9 is the hardest problem. All right, so again, simplify that on your own, and hopefully you get there. So 7, we have a new formula here to announce. If you're looking at it carefully, see if you can find it. It's a half power. It's kind of interesting, which is number 6. So this matches up with 6. And number 6 says t to the n minus 1/2 transforms into 1 times 3 times 5 times 2n minus 1. So what we need to do is figure out what n we're working with. And then times pi, and you got all the rest of it. So what n are we working with? Well, you can solve it if you need to. And that's just going to be 2. 4 halves minus 1/2 is 3 halves. So n is 2. So what does that mean for us? Well, the Laplace transform, according to number 6, is 1 times, well, it's 3 times 5, or just 2n minus 1. Plug in your number, you get 3. So that's where you stop. You have a pi inside, kind of weird, right? Weird how all this stuff relates to each other in mathematics. The deeper you go, the more perfect it is. 2 to the n, n is 2, so it's going to be 4. S to the n plus 2, n plus 2, n plus 1/2. So 2 plus 1/2 is 5 halves, right? So 4 halves plus 1. And there's your golden answer. Again, we match that up with number 6. So hopefully that makes sense. You just have to find your n. If you plug it into the formula where n minus 1 is, that tells you where to stop the sequence, which in this case was the second term, which is 3. And there we go. Number 8, you'll see the similarities. So on number 8, you just need to remove the 3 halves in front. There you have your t to 3 halves, so the Laplace transform for this, f of s, would be 10 to the 3 halves. That's still out in front. And then everything else that we just had. 1 times 3, so 3 square root pi over 4 s to the 5 halves. And that's an exponent here. That's the exponent of s. 5 halves is the exponent of s, and that's the answer. That's Laplace transform. Cool. Let's move to number 9. Last one. I was going to say let's keep it under 20 minutes, and the 20-minute mark hit. So number 9 is a doozy. It's kind of like a thinker. I'm going to hopefully try to get this right the first time in explanation, but it is a little bit tricky to explain. So we have t, again, g prime of t. So this is going to still match under the tn, and this is going to be like f of t. So let's do that for now. And that's going to be, again, -1 to some n power. And since it's this g, right, it's going to be g prime of s. All right, and so this is where it gets a little bit tricky. All right, how do I explain this? Okay, try to explain this on the side. Again, this is going to match number 30. So our function is g prime of t. And what does g prime of t tell you? Or what does f prime of t tell you in the equation? Well, it's number 35. So in our case, we have t to the n to some power times s g of s minus little g of 0. That's just a value there, right? So this is what we have so far. But we need the first derivative. So this is what the derivative is itself. We need the derivative of that. So we have to take the derivative of this term. Where did I write it clearly? Okay. So we got to take the derivative of this. Sorry for the pause. I'm just trying to make sure you guys understand. This is t to the first power. Taking the derivative of this, product rule. Derivative of s is 1 times g to the s plus s, and then it's going to be g prime of s. And that is just a value goes to 0. So this is everything. This is what it turns into. This is g prime of s. So g of s, the Laplace transform, is going to be -1 times g of s plus sg prime of s. Sorry for my chicken scratch, that's a g. Distributing the negative. I don't think I did a very good job explaining that, but that is the correct answer here at the end, Laplace transform. So basically, you are using number 30 at the start, right? Because you have t to some function. That function, because it's the first, we need the derivative of that function. But that derivative equation is this. So we have to take the derivative of this to match g prime of s. One more time, if you need me to, I'll try that one more time. So we start off by matching up, we have t to the first power, right? So we've done those before. That means we need to do the first derivative in our Laplace transform. So we need to do the first derivative of whatever that function is. Well, since the function started off as a derivative, we go to number function 35. 35, here it is. The derivative is the Laplace transform this way, kind of like the product rule, right? So now we're going to take the derivative of this because it's the first derivative. So this gets put in as the first derivative. Take the derivative, and there we go. So hopefully that kind of makes sense. All right, you guys take care. Hopefully the video kind of makes sense. Getting a little dicey here with Laplace transform. E hoodie out.